Hi guys, welcome back to my channel. So in this video, we're gonna do a review session because again, we're gonna have I'm gonna have like an exam next week about dosage calculation. So I'm just gonna go through like the notes and then kind of like try to remember how it works and how to solve problems using dosage calculation because it's been a while. So especially this summer, I'm not really taking any math class. So yeah, let's go through and hopefully I can still remember some of the concepts that we covered like few semesters back, right? So over here, because this semester we're gonna go over the pediatrics. So whenever you're giving medications to kids, right, pediatrics, it's gonna be smaller amount of course, and then the dosage can be like nearest 10 sometimes, or even hundreds over here. So the rounding rules for pediatrics in kilograms is rounded to the nearest 10. So whole number dot then the 10, tens, hundreds, thousands. So you need to round it to the nearest tens. But if you're doing IV fluids, it says here in our notes that it's gonna be rounded up to like the whole number, because if you have a pump, like PCA pump or infusion pump, right? There's not really like a decimal, so you have to like configure the amount to a whole number. So some of the common conversions that we usually use in nursing is converting, especially for dosage calculation. We use convert the pounds to kilograms. So in order for us to convert the pounds, we divide it by 2.2 kilograms. That's a conversion factor. So any weight then divided by 2.2, then that answer would be corresponding to how many kilos. And then we also need to remember that over here it says 16 ounces per pound. So if we have to convert an ounce to pound first, then we have to make sure that 16 ounces is equal to 1 pound. All right, so over here there's a caveat whenever we have to convert the ounces to pounds. It says here that we have to divide by 16, but we can't really round the answer yet, because whatever answer we get from that calculation, right, we have to add it to the given pounds in the problem so that we can actually get the correct amount of how many pounds, and then after that we have to convert it to kilograms after. So example here in our PowerPoint from our school, given 16 pounds 10 ounces, so we have to convert the 10 ounces first. So again, 16 ounces per pound, so 10 divided by 16 is equal to 0.625. so that's it. You can't really round it to the tens, 0.6, because again, it's still conversion from ounce to pound. And then whatever answer that the 0.625, we have to add it to the actual pounds on the problem. So over here, again, the 16 pounds, so 16 pounds plus 0.625, and that's going to be the total pounds. So the total pounds would be 16.625. Then after that, to convert the amount to kilos, we have to divide it by 2.2. And we have to again, instruction would be rounded to whatever is asked, if it's tenths or hundred. All right, those are again, there's more examples. And also over here in our ATI, we have to remember that again, 1 milligram is equal to 1,000 micrograms. So again, you just need to move. See, if you're going from smaller unit to a higher unit, you have to move to the left. But if you're going from a a large unit to a smaller unit, you go to the right, because again, it makes sense that if it's smaller unit, it's going to be more, and then if it's a larger unit, it's going to be less on what if it's a lower amount. Some things that are really hard, challenge to remember would be, example, 1 ounce is equal to 30 ml, and then 1 cup is 240 ml, 1 teaspoon is 5 ml, and then 1 tablespoon is 3 teaspoons. And there's also one that I rarely see this one, like the 1 grain or 1 GR is equal to 60 milligrams. So now I know, right? So one grain is equal to 60 milligrams. All right. Let's go ahead to the next concept. So that is just regular conversion. So whenever we're asked to solve for medication, especially if it's like opioid and stuff like that, we have to have another nurse, a licensed nurse, to actually verify the dosage to avoid medication errors. Because again, if you make a mistake in calculating, you can put somebody at risk, right? So might as well, especially if you're working 12-hour shift and everybody's tired, you can look up you can buy so just it's safer to actually have somebody to double check your calculation. So the example given over here was amoxicillin 215 milligrams PO every 8 hours. So there's different types of ways to calculate the answer. You can use the ratio and proportion, or you can also use the whatever desired medication that you need over desired on hand, and that would be the answer. Would be the answer would be the medication. The thing to remember with using that, the desired over hand, is you don't really round off whatever is on hand. Whatever unit you have on hand, that's it. The thing that you have to convert is the desired one, because how can you round off something that you don't have? So that's why desired over on hand would be you round off, you convert the desired one if needed. So example here, again, physician order amoxicillin 215 milligrams PO means by mouth every 8 hours. Suspension comes from 250 milligram per 5 ml. So using ratio and proportion, I would say over here, so 250 milligrams over 5 ml, and it's equal equal to 215 milligrams, because the 250 milligrams is the amount of amoxicillin that's given over X ml, because we're trying to look for the ml. It's not stated in the problem, so we're gonna represent the ml with X ml, and then using ratio and proportion, you're gonna cross multiply. So 250 milligrams times X ml, and then cross multiply 250 milligrams times 5 ml, and whenever you divide the two, that's going to be the answer. So the answer is whether you're using the ratio and proportion, and the desired overhand would be 4.3 PO every 8 hours. So every 8 hours can be written as Q8H. Example, every 6 hours will be Q6H. I just probably need to remember, there's some words that are can't be used now, so no abbreviation, because if you use those abbreviations, it's prone for medical error, so you have to not use it. So example, if the exam says MGSO4 or whatever, if it's not on the authorized list, then you have to say that it needs to be spelled out, or you have to actually word say the word for that term. All right, so whenever we're the next topic would be safe dose range. So convert pounds to kilograms. and that's weight is in kilograms, so it makes sense. Calculate therapeutic range for the patient. So whenever there's going to be questions that would tell you what's the safe dose range for this person or kid. And also they would tell you the safe dose range would be from this minimum, like how many mg or whatever unit, to this one. So if the answer of your calculation falls between those two ranges, right? So it's safe to administer. So it's yes. If the answer is out or either like above the max range or below the minimum range, then it's not safe to administer. And there's also some questions over here that they give, like there's only one, like safe dose is this one. So if the answer is different from that specific amount, then it's basically not safe to administer. All right, let's try to. So in the question that they gave over here, so the order was 68 milligrams acetaminophen or Tylenol, which is the brand name. There's different names of what they call the medications, right? So there's a chemical name, like the chemical molecular composition of the drug. Then also the generic name, and also the brand name. The brand name is like, you would know because it's capitalized, Tylenol, it's capital T-Y, and then the generic name would be lowercase. Over here, again, it says here, the example of the question was like 68 milligrams acetaminophen, and then the patient weight is 15 pounds. And then safe dose range is 10 milligrams per kg per dose. So how do we solve the problem? So the first thing is we have to convert the pounds to kilograms. So 15, given is 15 pounds, right? So we have to convert it, divided by 2.2, and the answer is 6.8. And then in order for us to calculate the safe dose range, we have to multiply that answer of the kilos to the recommended safe dose range, which is 10 milligrams per kg per dose, and the answer is 68. Since 68 is the one that's being ordered, and then we calculated 68, so exactly the same, then it's safe to administer the medication. Alright, I gave more example. I'm just gonna go over like the concept. I'm not really gonna. Alright, so let's go ahead and talk about daily fluid needs. So this is my first time knowing this one. So fluid needs should be calculated every patient to assure that the infant or child is receiving the correct amount of daily fluids. So a formula is calculated to calculate the daily maintenance fluids in pediatrics. And then, so for pediatrics, it's kind of like, it's based on weight. So it says here, if you're calculating the daily fluid needs of the pediatrics, so the first 10 kilograms of the weight of the baby, it's going to be 100 ml of fluid. The next 10 kilograms of the baby, so example 11 to 20, it's going to be 50 ml for the daily fluid needs. And then anything above the 20 kilos, example like 22, 23, it's going to be 20 ml of fluid for any additional kilogram of weight. So example 22, so 2, it's over 20, like by 2 kilos, so times 20. So you're gonna have to add like 40 ml of fluid. And then the daily maintenance fluids are the amount of fluids that the child will receive over 24 hours. Alright, example that was given, alright, Jose, which is the name of the baby, is 16 pounds. How many ml of fluid does he need in 24 hours? How would you program the pump to deliver his fluids? So again, we have to calculate the weight first. So 16 pounds divided by 2.2 is equal to 7.3 kilograms. and then we plug in the formula. So 7.3 kilogram, again, the first 10 kilograms of the weight of the baby or the kid is 20 ml, right? So, oh no, 100, sorry, 100 multiplied by 100. So 100 ml times 7.3 is equal to 730 ml. So Jose needs 730 ml fluid over 24 hours. And then how do we program the pump, which is the one that delivers the fluid to the baby? It's delivered, it's delivered in the via ml per hour. So that's how you program the pump. So we're gonna get the answer so we calculate 730 ml, and it's for 24 hours for 1 day. So it's gonna be 30.4 ml per hour. That's the amount of fluid that we're gonna have to set up the pump to deliver the baby. All right. Again, we can't really, over here it says that we can't really give an answer of 30.4 because it's IV pump, so we have to round it off to the nearest whole number. So 30.4 again is below 5. The decimal point is below 5. So we have to round down. So it's going to be 30 ml per hour. All right, they gave more practice. All right, so the next concept over here. So what if the child has sickness, right? So they're losing some fluid, so you have to, to also, aside from the daily fluid needs, you have to also give additional fluid because of the condition or what is going on with the kid. So, example, if the kid is dehydrated, has fever, is vomiting, they're losing fluids, right? So every 24-hour fluid calculation may be ordered at 1.5 to 2 times the maintenance. Again, if they're losing fluid, they can be ordered 1.5 to 2 times maintenance. So going back to the last example, Jose, which is 16 pounds, and then he requires 730 ml for 24 hours, and then the provider ordered 1.5 times maintenance. How much fluid would you give? So 730 ml times 1.5, which is the amount ordered, is equal to 1,095 ml over 24 hours. That's the amount. So in 24 hours, you would give 1,095 ml. And you would program the pump. So again, it's for 24 hours. So 1,095 ml divided by 24 is equal to 45.6. And again, we can't really have a decimal place on this one, so we have to round off to a whole number, and then it's 0.6 above 5, so it's going to be, instead of 45.6, it's going to be 46 ml per hour. Alright, so another example over here is new to me. So if an infant or child has a nasogastric or OG tube or wound that is draining fluid, the physician will often write an order for replaced output 1:1. That's a new scenario, right? So example, over here they were saying that if the kid has a wound, or they have a tube, then sometimes the doctor would order 1:1 replacement. That's the ratio. So output is measured every 4 hours. So you have to monitor the output. That's why sometimes nurses are asking. For this one, I'm guessing if it's pediatrics, right? The child would not really be the one monitoring how much they drink or not. So it's gonna be either the nurse, or based on whatever, how much they drink, or the IV pump setup, or the caregiver, or the parent. Output is measured by Q4 hours. Every 4 hours you will measure the output and then replace the amount over the next 4 hours. So whatever is lost on that 4 hours, you have to also add it to the daily fluid for the next 4 hours, because it's 1:1 replacement. So over here again, it's kind of highlighted. Replacement fluids are in addition to the oral IV hourly rate or daily maintenance rate. So example, during the shift change, the one that giving the nurse before you tells you the energy output for the last 4 hours is 120 ml, and the patient's daily maintenance fluids are running at 120 ml per hour. How many ml per hour will you program your pump for the next 4 hours to be able to recover the output? Over here, first calculate the replacement fluid. So again, the output was 120. You have to divide it by 4 hours because you have to recover it by 4. So you have to add additional 30 ml per hour on the daily maintenance. So the daily maintenance also is 120. So 120 ml plus 30 ml additional is equal to 150 ml. So we have to program the pump to run at 150 ml per hour for the next 4 hours. So that's the solution to the problem. All right, and that's the end of the review over here. But again, there's more stuff that needs to be learned for dosage calculation. I think also the 5 rights of medication: right patient, right patient, right dose, right route, right time, and then right documentation. So those are the 5 rights. And also you have, whenever we're checking for the medication, right, we have to check it before we pull out from the med card. Before we mix it, we prep it, and then before we administer it to the patient, we have to do the 5 rights of the medication. There's different routes also whenever giving medication, but not exactly for pediatrics. So I'll try to remember. So IV intravenous, which is the fastest one. Then inhalation would be the second one. Then intramuscular would be the third fastest route. Then subcutaneous would be whenever you're giving insulin. And then the slowest route for med administration would be the oral. So that's going to be the oral. So, alright guys, that was it. So thank you for watching me or also trying to review with me. Alright guys, take care, have a nice day.